Hello everyone. In this video, we will discuss the problems of the CSES problem set in the sorting and searching section. And this is part 1 of the series. So in this video, I will discuss the solutions till playlist. And if this video does well, then I'll probably make a part 2 where we can discuss from towers till somewhere nearest smaller values. And in part 3, we can discuss the subarray problems, the harder ones. Okay, and maybe I will also make a playlist for the DB and dynamic programming problems also. Yeah. So if you have any doubts, you can comment down. I generally read all the comments and generally reply to them, or you can reach me on Instagram or LinkedIn if you want. So let's start. So the first problem is distinct numbers. And the problem statement goes like, you are given a list of n integers and your task is to calculate the number of distinct values in the list. Let's read the input format. It is first line contains an integer n and the second line has all the integers x1, x2 till xn. So basically, and let's see the example 5. So we will have 5 numbers 2, 3, 2, 2 and 3. And we can see the only distinct numbers are 2 and 3 here. So our output is 2. So to find out the distinct numbers, we obviously need a data structure which will maintain all the distinct values. So, and in most cases there are two data structures that we can use here. One is a set and another is a map. So we can use a map to find the frequency of all these numbers or something like that, or we can simply add all these elements in a set and find the length of that set, right? So and we can solve this problem. So let's just see the code. Okay, so here I have shown all the code in all the three languages, Java, C++, and Python. So in C++, you can simply create a set and add all the elements using s.insert. In Java, this is my template. So we are doing the same thing like that in C++. First take an integer t, create a set and add all the elements in that set, and finally we are printing the length of the set. And same thing we are doing in Python. First take the input, and I have not converted each character to a number because that will be time consuming and might give me a TLE. And just convert that string of characters or list of characters to, or I should say list of strings to a set, and then simply find the length of that set. Okay, so all these three this is one of the approach that you can follow to solve this problem. And let's move to the next problem. Okay, so this problem is called apartments. Let's read the problem statement. There are n applicants and m fee apartments. Okay, so your task is to distribute the apartments so that as many applicants as possible will get the apartment. Each applicant has a desired apartment size and they will accept any apartment whose size is close enough to the desired size. And the input format is, first we have, in the first line we have 3 integers n m k, the number of applicants, the number of apartments, and the maximum allowed difference. Okay. So basically you can read the input format. So first we have 3 integers 4, 3 and 5, and these are the apartment size that we have, and these are the requirements, and we want to sell maximum number of apartments. So basically we want to maximize the profit, right? So let's first understand this. So we have 4, 3 and 5, 4, 3 and 5, then 60, 45, 80, 60, that is the apartment size. So this is our apartment size, and this is our requirements. Okay, now we want to okay, so basically the 30th, when our requirement is 30, it can take from 25 to 35, right? But since we do not have any apartment in this range, we cannot give this person any apartment. Okay, now for 60, it can take from 55 to 65, and obviously we can take either this one or this one, right? Both will work. So we have two options, either we can take this 60 or that 60, one of them. And for 75 we can go from 70 to 80. So we only have one option, that is the 80. We'll assign this and we will assign this one. So in total we were able to sell 2 apartments, right? So that is our answer, I think. Yeah. So that is how we get 2 as our answer. Now how will we how will we solve this problem? First we should first let's see another test case. Okay, so these are our apartment sizes: 2 units, 2 units, 40 units, and 41. And our requirement is 40 and 41. So the person with requirement of 40 will take apartments from 38 to 42 actually, right? And the person with so he will be able to take both the apartments 40 and 41. But the person from 42 will take the apartments from size 40 to 44. So he is only able to take the apartment size of 41, right? Actually, let's consider this as 43 to make this a better test case. So we will consider from 41 to 45. So he will be only able to take the apartments, the 41 apartment, right? So in order to maximize this, we must assign this 40th person the 40 size apartment and not the 41. Otherwise we will not be able to assign that apartment to the second person, right? So obviously this problem will involve some sort of sorting, because we want to assign the smaller apartment to the first person that comes, right? So obviously we need to first sort both these arrays. Okay, then what we can do is, okay, I will say I will have 2 pointers, I and j. Okay, now first I will check if this is, if I can assign this to the ith apartment. If not, then I will move this pointer. I still can't assign, I will move this pointer, so j will point to 40. Now I can assign this problem this apartment to this requirement, so I will increment both these pointers. And if there is a case when I can't assign this to this one, then I will not increment by j and increment the ith pointer. And so basically this problem is of 2 pointers, and using sorting and 2 pointers we are able to solve this problem. So I hope you were able to get it. Sorry for my bad handwriting. Let's see the code. Let's see the code, and that will make it more clear. So I will show you the codes in I will show you the code in C++, Java, and Python one by one. Basically, first we want to take input both the arrays, okay, and then we will simply sort both of them. Okay, now I have 2 pointers, I and j, and I'm counting the number of apartments I am able to sell, right? And now if you see, okay, obviously my while loop will run from till I reach one of the end of the arrays, right? And now if my requirement minus k is greater than the ith pointer, then obviously I can't assign that requirement to any apartment, right, that I have. So obviously that requirement will go unfulfilled, so I will increment my jth pointer. Otherwise I can otherwise if the requirement is, if the currently I am at is I am too high but the apartment is too low, then obviously I still can't assign it. I will increment my pointer. Otherwise I will assign them and I will increment my count as well. And in the end I just need to print out the count variable. Similarly, if you want to see the Java code, that is also the same implementation. One thing that I would say is, do not use arrays.sort in this problem, because arrays.sort uses the worst case complexity for almost sorted array is O of n square. So what you can do is first shuffle the array, or I mean there are several ways. You can either use radix sort, or merge sort, or some other sort, but do not use arrays dot sort for this, otherwise it will give you a taily. Or you can simply use arrays dot or you can first shuffle the array randomly and then use arrays dot sort. That will solve your problem. Okay, so what I am doing here is I have created the function for merge sort, and that will solve the sort my array in n log n, and that will avoid the taily. Okay, and similarly in Python, first you make both arrays and then you sort them, and using 2 pointers I'm able to solve this problem. Okay, so our next problem is Ferris wheel. So let's read the problem statement. There are n children who want to go to a Ferris wheel. Your task is to find a gondola for each child. Each gondola may have 1 or 2 children in it, and in addition, the total weight in the gondola may not exceed X. You know the weight of every child. What is the minimum number of gondolas required for needed for the children, right? And the input format is the first line has 2 integers and an X, and the next line contains n integers. So P1, P2, weight of each child. Okay. Now n goes from n goes straight to into 10 to the power 5. So it is asking for an n log n solution, and xi is still x is still 10 to the power 9, and pi is still 10 to the power 9. Okay, so I hope let's see this test case. So 4 10 7 2 3 9. So 10 is the maximum weight of the gondola that is allowed, and these are the weights of the children. So okay, so let's say we assign 7 to a child. So every gondola has 2 seats, right? Maximum it can accommodate only 2 children. So let's say there is a gondola with a child with a 7 in it, and then okay, we can place 2 here also. In the next gondola we have 3 here because 3 was free, but now we can't place 9 because because the maximum is 10, right? So obviously we will need another one, and in that 9 will be sitting alone. So in this case, for this distribution we need 3 gondolas, right? But obviously there could have been another distribution where 7 and 3 were sitting together, right? And 2 was sitting alone and 9 was sitting alone, right? So in that case also we will need 3 gondolas. So I think the answer should be, for this test case, the answer should be 3. I should just take the minimum of all the possible cases and we have to print that answer, right? So this is also a standard problem of 2 pointers and sorting. So the concept here is 2 pointers and sorting, right? Now how do we go about it? So we have 7 2 3 and 9, right? 7 2 3 and 9. First what we will do is we will sort this array 2 3 and 7 and 9. Okay, then we will keep 2 pointers I and j pointing to the first and last element, and we know that our maximum size is 10, right? So if I do 2 plus 9, that is array of I plus array of j, whatever, then that is giving me 11. So obviously if I increase my I, that is going to increase my answer. So what I will do, I will assign the jth pointer 9 to a separate gondola, right? And then I will move my jth pointer here. Now let's see array of I plus array of j, that is 9, right? 7 plus 2 is 9, and that is less than my maximum required. So I will assign a gondola to these 2 children where 2 and 7 will be sitting together, and then I will increment my I and decrement my j together. Okay, So now my I is also pointing here and J is also pointing here, and obviously I need to assign a separate gondola for the 3, and 3 will be sitting alone in that gondola of the Ferris wheel. So this is how we will get our answer as 3. And since we are sorting, so that will cost us an n log n time, right? And if you are using radix sort, you can improve it till a big of n. That will be even faster, right? But in general we don't use it, so it will an n log n solution will work here. Now I think you were able to understand the approach. Now let's see the code. Now I will show you the code in Java and Python also separately. So first what we will do is we will take the input n and x, then we will take the array input, the vector, right? And after that we have to sort all these elements. We have to sort the array. Then we will make 2 pointers I and j, pointing to the first and last element of the array. Then we also have an answer variable, and now we will check the sum of the first and the last pointer, and if that is greater than x, then obviously I have to increase my answer, obviously. But I can only decrement the j because I am assigning that gondola to only the last pointer. Here it was 9th, so I'm saying that okay, 9 will sit alone in that gondola, so I'm only decrementing the jth pointer. Otherwise, if the sum is less than x, then I can assign it to the same person, right? If that sum like 7 plus 2 was 9, and that is less than or equal to my 10, right? Then I'm saying that okay, 7 and 2 will sit together in that gondola, and I will increment my ith pointer and decrement my jth pointer. So that is what I'm doing here. And in the last case, if I and j are equal, then I will say answer plus plus, and that will be my answer. Same code in Java. You can say first I am taking n and x and as an input, then I am taking the weights array, then I am using merge sort here. So again, kindly do not use arrays.sort here, because the worst case complexity for an almost sorted array is n log n. So it is advisable to use merge sort, or you can also use ruffle sort. There was a Codeforces blog on this, and that is where I read it. So you can use something like this, where we first randomly shuffle the array, and then we use arrays.sort to sort the array, right? Or you can, and the best method is, I think it is to use radix sort, because it is not a comparison based sorting, and that will even more improve your time complexity and even more reduce the time, right? So however, in this case I'm using merge sort, which also passes all the test cases. So you can sort, first we have to sort this, and now that same approach we are taking 2 pointers and doing this. Okay, so you can read this, and similarly we have this code in Python. Okay, so again same thing, and count, and I think you get the idea, right? Let's move on to the next problem. Okay, so let's move on to the next problem, concert tickets. Let's read the problem statement. There are n concert tickets available, with each with a certain price. Then m customers arrive one after the another. Each customer announces the maximum price they are willing to pay for a ticket, and after this they will get a ticket which is nearest possible price such that it does not exceed the maximum price. Okay, now then you can read the input format, and let's just discuss the sample test case. So we have 5 tickets available with us, 5, 3, 7, 8 and 5. Then 3 customers arrive one by one, and first customer says that he is willing to pay maximum price of 4. So one way is we have to search the number closest to 4 which does not exceed 4 in this whole tickets array. So obviously that number is 3. So we will assign the first customer the ticket value of 3, and now the tickets that are remaining with us are 5, 7, 8, and 5. Okay. Then the next customer arrives with and he says that he wants a ticket price of 8. So uh, we will give him the ticket price 8 because that is the maximum he can pay. Then we are left at 5, 7, and 5. And the next customer says that he is willing to pay maximum of 3. Then so but we don't have any ticket with price less than or equal to 3, so we will say a -1. So this will be our output, and this is the case. Okay. So now how do we solve this? And this is actually one of the popular problems of CSES problem set, and I think and this is not an easy problem. And what makes this problem difficult is you cannot solve this problem using elementary data structures like sets, right? I mean, C++ provides the data structure, but still it is not a very easy problem. Okay, and that is we can figure that out by seeing the submissions in this. Like, okay, let's just cut that part out. Okay, so how do we approach this problem? So I will give you three approaches to solve this problem. So let's discuss the first approach. Okay. So obviously we need to sort this. Uh, so obviously whenever a customer arrives, we want to find the closest price of ticket that is the available, right? So some sort of binary search will be there. So to make the searching part quicker, right? So for to make the searching part quicker, what we can do is first sort the array, obviously. So we had 5, 3, 7, 8, 5, and 5, right? Now if we will sort it, we will get 3, 5, 3, 5, 5, 7, and 8. And now we can simply use functions like upper bound in C++, or we can use ceil in Java. And if you are a Python user, you can also use what was that, bisect right in Python to query the maximum ticket that is available in this sorted array in log n time, right? So this is for the searching part. Like, okay, this will give you for the first customer. He says he wants a ticket price of 4. So you are able to query this 3 in log n time. But the part that makes this question difficult is how will you remove it? Like because in Python and C and Java especially, or if you are using vectors to store this so if you are using vectors to store this even in C++, if you are using vectors to store this these array, if you remove this 3, it will take a big O of n time for deletion, right? And if you follow this method, big O of n time deletion and log n time querying, so it will be big O of m times like n for deletion, and for querying it will be log n. So this goes to O of n square, right? And this will give you a TLE. So we need a data structure, like what kind of sorry, what? So we need some kind of data structure with log n time for searching and log n time of deletion. And what are the different data structures that can achieve this? So one is using multisets, right? Second is using segment trees. And third is using DSUs, the disjoint set unions. So we will discuss this one by one, and I think I will discuss them in this manner only. Like first we will discuss multisets, then we will discuss the segment tree approach, and then we will discuss the DSU approach, right? So what is happening here? Like what is the difference between multisets, segment trees, and DSU? Multisets is basically a data structure which is similar to a set. So this is maintains the sorted order. So this maintains sorted order, and the insertion deletions in login time, and also and provides methods like upper bound and lower bound to query. So let's just discuss the multi-set approach. Okay. So what we can do is we can simply add all these elements. Like we don't even need to sort them. We can simply add all these the whole array in a multi-set. So this will become 3 5 5 7 8, right? So 3 5 5 7 and 8. Of course this is not a vector, so deletion time will not, now the deletion time will not be that O of n. The deletion time will be log n, and we can do brute force of deletion to reduce this to big O of log n, and we will do the same thing, just we will not use a vector, but we will use a multi-set, and that will improve the time complexity, right? So let's just see the code for this one. Okay, so I have C++ and Java code for this one. Unfortunately, multisets are not inbuilt in Python, so we can't use them. I mean, but Python does not has any data structure for the sorted order traversals, so we can't do that. Okay, so let's see the C++ and Java code for this one. So we can take the first, we have to take the NNM input, then we will define a multiset for tickets. Then I will simply add all the ticket prices in this multiset, and this will maintain a sorted order of the tickets. Then one by one person will come. So I will take the upper bound of it. So I will find the ticket which is greater than x, and then I will if that is if that is at the beginning, then obviously the smallest ticket is not even that, right? I'm not able to give the smallest ticket also. I will simply say -1. Otherwise, I will simply erase the ticket and print the ticket. So it is pretty simple and straightforward. Let's see the Java code for the multi-set approach. Now it might look a bit messy, but I mean large code, but it is not. Much of it is basically the template. This is for the fast input output, and this is code for merge sort. Okay. Now obviously Java does not have a multi-set inbuilt data structure, right? So you can't use multi-set here, but but it provides set data structure which maintains the order of the elements in the sorted order itself. So what you can do is you can make a comparable structure, and you have to specify your own comparator in it, and the tree set the tree set will do the trick. Tree set will maintain the sorted order, and uh, obviously the sets do not allow duplicates, right? So you can maintain a pair of you can insert pairs to avoid that problem, right? So I have inserted the pair of pair, and the second element should be unique to everyone, so that it is no two elements are same. And then I have converted the set to a multi-set by using pairs. Now once you do that, you can use the floor function and the ceil functions to query in login time, and then it is basically the same thing. So I hope you are able to understand this. Okay, let's move on to the segment tree approach. Here I would recommend you to either skip ahead or do something like that. If you don't know the segment tree, you should first study it and come back here. So segment trees approach. Okay. So we have 5 3 7 8 5, right? Okay. We have 5 3 7 8 and 5. Okay. Obviously, first we need to sort them. So after sorting, it will become 3 5 5 7 and 8, right? Okay. Now we have 1 2 3 4 5 5 elements here, and the closest power of 2 is 8, right? So just to balance the segment tree, I will add 2 more 5 1 2 3 4 5 6 7 8, 3 more infinities here. Okay. Now I will create a segment tree. So uh, the minimum of these two is 3. The minimum of these two is 5. The minimum of these two is 8, and these two are infinity only, just to make it a bit more structured manner. Otherwise the segment tree will not be balanced, and it might happen that the leaf node are, you know, like that. So I just added 3 more infinities to make it look like a triangle, just to make it more presentable, right? So this completes my segment tree. So first thing we did was sorting. Second thing I did was building the segment tree. Now the customers arrive one by one, right? The first customer tells me that, okay, so now the first customer is comes and says that he wants to buy a ticket with the price of 4, right? Let me just change the color of my pen for this one, or I will use a laser for this one. Okay. So now first customer tells me that he wants to buy a ticket of maximum price of 4. So obviously now 4 will not be in this right subtree, right? Because the minimum element of this right subtree is 8. So we will say, okay, no problem. Let's move on, go to this subtree. And in this subtree, we've reached at this node. Now the minimum is 4 obviously. Okay, sorry. The minimum is 3. Now we can either go right or we can go left, but the minimum here is 5. So 4 will not be able to come in this subtree. So we'll go left. And similarly, we can't go here. So we'll go left. So first we went here, then we went here, then we went here. Okay. Now we will assign this 3 and mark here infinity. Okay. Now we will backtrack our solution. Like, okay, now we came this way, so now we will have to traverse back. Okay. So we go up and update this. So now this will be updated to 5. This will be again be updated to 5. We are simply taking the minimum of the children again, but this was infinity, so we have to backtrack, and this will change to 5. Okay. The next customer arrives and he says, okay, he wants a price of 8. So we go right, left, and left. So we will cut this and make this infinity. Then we go up, take the minimum. This will also become infinity. This will also become infinity, and this will remain as 5, right? And next customer comes and he wants a price of 3. Now when he wants a price of 3, even just from the first element, I can say that there is no element in my whole segment tree, the leaf nodes of the segment tree, that are less than 3, because the root node always contains the minimum of all the leaves, right? So I can simply say here -1, right? So this will also like this is actually even more efficient than the multi-set space wise, because going down is log n time, and going up in updation is also log n time, right? I mean, it sounds the same, but it is much less complicated than the segment tree on the backside. I mean, the code will obviously be much longer than the multi-set, but efficiency wise, the segment tree approach is obviously much easier to implement. Okay, let's see the code. Yeah. Uh, okay. So first we have a function to build the segment tree, then the update the segment tree. Like, okay, obviously I will first normalize the number of elements to the closest power of 2. Then I will keep going up and take the minimum. Next we have the update segment. So as I go backtrack upwards, I have to take the minimum of the of the children, right? And then I have to query the index of the segment tree. So that is this. Now I will take the NNM, and I will store the tree in a vector. First I have to sort and then build. Okay, so first I will sort all the elements of the tree, and then I will build the segment tree. After that I can query the elements, and then if that result is not 0, because this segment tree, this code is using 1 based indexing, I will even mention it here. Okay, so since this is using 1 based indexing, result is 0 means that the element is not even present in the segment tree, right? Or if the result is infinity, then obviously I can't assign it. I'm using math.intmax as my infinity value. So if the result is infinity, I can't use this. Okay, so I will say simply update the segment tree. Otherwise, I will print -1. Okay, let's see the Java code. So this is also the same thing. I just didn't want to use arrays.sort to avoid the TLE that may happen, may not happen. So I just use the radix sort to optimize it a bit. The rest of the functions are same. The query segment tree, update segment tree, and here I am building the segment tree. And similarly, I am just querying. You don't even need to leave it. Okay, so similarly, I am just querying the segment tree and printing the result. Okay. By the way, if you want this template of my Java code, I will provide that in the description of this video. And if you have any more approaches, like more than other approaches, like some other data structure, you can even mention them in the comments below, or just for others to know. Okay. I think I also have a Python code for this one. So even that is also the same thing. You can try and implement it in Python. It will also pass all the test cases. Just run it in PyPy3, not C Python. Okay. Let's also see the DSU approach. Or I think I should just show you the code instead of writing this one. So I don't feel like explaining this DSU one. You can just check out the code and try to understand it yourself. If you don't get the approach, if you are not able to understand this approach, I will probably make a separate video on this particular problem, because this is a very good problem and it can be solved by various approaches. So we can make a separate video and try to go in-depth for an in-depth solution. Okay. So the Java code is this one. And this is the code for merge sort, and I had to implement the upper bound separately, and this is using the DSUs. Okay, and I think this is the using the DSUs is the most optimal, because it is even more space optimized and time optimized, and this is using the Python. Okay. I hope you were able to understand it. If not, you can just comment down the description, comment down this video, and I generally read all the comments and reply to them. Okay. Let's move on to the next problem. Okay, so let's move on to the next problem, restaurant customers. And the problem statement is you are given the arrival and leaving times of n customers in a restaurant. What is the maximum number of customers in the restaurant at any time? And you can read the input format, and the constraints are n goes to 2 into 10 to the power, 10 to the power 5. So it is asking for an n log n solution, n log n time solution. And A and B, the arrival and leaving time can go till 10 is 1 and obviously the arrival time will be less than the leaving time. Yeah. So basically the customer at least stays for 1 unit of time. Okay. So we have 3, 5, 8, 2, 4 and 3, 9. Let's see this. We have 3 customers. One arrives at 5 and leaves at 8. And the second arrives at 2 and leaves at 4. And the third customer arrives at 3 and leaves at 9. So for the first customer, we can say he comes at 3. He arrives at 5 and leaves at 8. 8. The second customer arrives at a time of 2 and leaves at the time of 4. And the third customer comes at time t equal to 9 and leaves at time t equal to comes at time t equal to 3 and leaves at time t equal to 9. Okay. And now we have to check, like for this time interval we had no customer. For this time interval we had no customer. For time for 2 to 3 we had only one customer. For 3 to 4 we had two customers, and here we had 1, then 2, then 2, then 2, and here we have 1, and this goes till 10 to the power 6, right? Because the arrival and leaving time are from 1 to 10 to the power, it goes to 10 to the power 9, and this goes on like zeros, and after that you have to take the maximum of these values, and this will give you 2 because the rest are zeros, right? So obviously this will not go to delta, so obviously it is not possible to store all these times, right? Because we can't make a vector or an array of this much length. And how are we going to make this graph? How do we take the maximum of each time, right? So obviously we can't do that. So this is a graph problem, right? So obviously okay, so I've just tell you the concept. This is, to solve this you need to know a concept called sweep line algorithm. So you can't solve this without without knowing about the sweep line, and it is pretty obvious. Like a customer arrives at 5 and leaves at 8. So when he arrives at 5 plus 1, a customer will be added, right? And when at t equal to 8 minus 1, so a customer will be leaving. Also from 2 to 4, like at time t equal to 2, a customer comes into the shop, and at time t equal to 4, a customer leaves the shop. And similarly for 3 to 9, at time t equal to 3, customer enters the shop, and at time t equal to 9, a customer leaves the shop. So now we will make pairs, like okay, so for every, like at time t equal to 5, we have like at time t equal to, okay, so let's just first I'll make these pairs and then I will sort them. Okay, so at time t equal to 2 we have a customer entering the shop. Then at 3, so here we will have a plus 1. Then at 3 we have 2. Then we encounter a minus 1 here, so here we will have 1 again, then 2, and so on. So basically we are I'll just show you through the code how this is implemented. because it is tough to explain it here. So let's see that. So basically what we do is we make a pair, a vector of pairs. Like we are trying to store pairs in this. So the input format is, first we have an integer and then we get pairs. So basically, like whenever the customer arrives, like x and y, the arrival and leaving time. When the customer arrives, I will add +1 to the answer, and when the customer leaves, I will add -1. And once these are, once I have this vector of +1s and -1, I will sort them. Okay, like if like I can't print that, but after this sorted, this will become something like 2 comma +1, then 3 comma +1. My L will look like this, like 2 comma +1, 3 comma +1, then 4 comma -1, then 5 comma +1, then 8 comma -1, and 9 comma -1, right? And now take the just keep taking the second value sum. So 1 2, then 1 again because this is -1, then 1 again, sorry, 2 again, then 1 and 0, and take the maximum of this. That is our answer, right? So I hope I was able to explain this algorithm properly. Otherwise, you can try and Google it on your own, or you can just read this code. It is not very difficult to understand. So basically, we are uh, taking these pairs and sorting them, and I'm taking the prefix sum of the second values and taking the maximum of it at each step. So this is the Java code. I make pair object, and then I add new pairs, and then I use collection.sort. Similarly, we also have the Python code, and all of these code will pass all the test cases. So that was an easy problem. Let's move on to the next one. So let's move on to the next problem, movie festival. And the problem statement goes like, in a movie festival, and movies will be shown. You know the starting and ending time of each movie. What is the maximum number of movies you can watch entirely? Now you can read the input format, and output is we need to print one integer, the maximum number of movies we can watch, and n goes to 2 into 10 to the power 5, so it is asking for an n log n solution. So let's see the test case. 3 comma 5, first we have 3, then starting time is 3, ending time is 5, 4 comma 9, and then 5 comma 8. Okay. Now let's say the first movie starts at 3 and ends at 5, right? And another movie starts at 4 and is ending at 9, right? And another movie is starting at 5 and it is ending at 8. Let's say somewhere here we have 8 and then we have 9. 8. Okay. So if let's say there was one more movie, like obviously we can see that we want to watch this one first and then this one, right? Because as soon as this movie ends, another movie starts at 5. So we will be able to watch two movies. Otherwise, if we did not select this one, we selected this one, then we will only be able to watch one movie from 4 to 9, right? So this is a very standard greedy algorithm, and I will just write the statement. I mean, in such kind of problems, we basically either have to sort by the start time or the end time, right? And to watch the maximum number of movies, we want these. And yes, right. Like if we want to maximize the maximum number of movies, our movies should end quickly. So the end time should be as small as possible. So first, what we want to do is sort by end time and then count. So very simple, a simple problem. First, just sort it by end time and then count the maximum number of movies you can watch. So let's see the code. First, I'll make a vector of pairs and then push the movies in that. Then I want to sort them by the end time. So I will have to pass a custom comparator in this, like this. And after that, I just need to count them. So obviously, I will need the end time of the current movie that I'm watching, right? So, so sorry about that. So uh, if the end time is less than the start time of the movie, then I can watch that particular movie, and I will uh, uh, update my end time. Otherwise, I will not be able to watch the movie. So I will move on. Now, then I just need to print the count variable. Let's see the Java code. Okay. So in this, in the comparator, in the pair struct itself, I can specify the compare to function here. Like first, I will compare the second value and not the first one, and then if that is same, then I will compare the first integer. So I just use collections dot sort, and then the same thing. Okay. And similarly, we can do the Python code. Just specify that you want to sort it by the first second value, right? After that, it is sorted by the second value, and you can do it. So I hope you were able to understand it. So let's see the next problem. Sum of two values. You are given an integer of an you are given an array of n integers, and your task is to find two values at distinct positions. So the values can't be at the same position, and whose sum is x. So you can read the input format, and we need to print two integers, the position of the values, and if there are several solutions, you may print any of them. If there are no solution, then you will print impossible. So let's understand the let's understand the sample test case. For it, we have 4, 8, and 2751. 2751. So this and this will second and fourth position will make the sum 8. So we can print either 2 comma 4 or 2 and 4, or we can print 4 and 2. Both will give me the correct answer. And here it is written 2 comma 4. Okay. So, n goes till 2 into 10 is per 5. So it is asking for a big O of n log n time solution maximum, right? And this is actually a pretty popular problem on LeetCode. I think it was the first problem by the name 2sum. But in that we didn't have to print the I think I will just Google search it for you. So this is the first problem of LeetCode. So this is actually a pretty popular problem, but in this we don't have to print the so this is the same problem. You can even go to the editorial or the solutions menu to find the solution about this. Okay. So there might be several solutions to this. I will give you two approaches. So let's discuss approach one. Yeah. And now obviously since it is asking for a big O of n log n solution, we need some sort of sorting, right? The first approach is by sorting plus two pointers. and this will be a big O of n log n solution, assuming my sorting is taking n log n time, because we generally use comparison based sorting. So when we sort it, this array will become 1 to 7, 1 to 5 and 7, right? And just like in the Ferris wheel question, I will have 2 pointers and I will check the sum. If it is greater than x, I must decrease the right pointer. If it is less, I will increase the left pointer. And if it is equal, then I have arrived at the solution, right? uh, Also, we don't want to print the numbers, we want to print the position of these numbers, right? So first, we need to have some way to map value to index, right? First, we need to create this map of integers, or we can even use arrays for that, or you can create pairs. Like instead of storing this, first we will convert this array to 2 comma 1, then 7 comma 2, then 5 comma 3, then 1 comma 4, and then sort this array by their first values. So after sorting, it will become like 1 comma 4, 2 comma 1, 5 comma 3, then 7 comma 2. Then we can use the same approach for the first values, and while printing we can use the second values, right? So this is an n log n solution. There is one more approach. If we want to improve our time complexity to big O of n, like this is big O of n log n, right? But this is big O of n log n time, and the space is constant. We are not using any space, right? So if you want to improve the time to big O of n, then obviously you have to trade time and space, right? So we will be using some kind of space to optimize it. So what we can do is we can use hash maps or sets to solve this problem, or we could even use sets plus vectors, I think. So both of these will take big O of n space, and I think it will be better to explain it by the code instead of showing you, instead of writing all this, right? So let's quickly see the code for this one. Okay. So one way is I prefer using pairs. So I will create a vector of pairs and push all these elements. The first value will contain the element, and the second value contains the position. Notice that my for loop goes from 1 to n and not 0 to n minus 1. Okay. Then I will simply sort it by the first values and apply 2 pointers like in the Ferris wheel question. And if I did not find it, then I will print impossible. And while printing, I must print the second values because it stores the index of that element. So similarly, there is a Java code, code1.java. Yeah. So in this, we will create a pair element and do the same thing. I think it is pretty clear. And code1.python. Yeah. Okay. Now let's see the approach to code2.java, or start. Okay. In this, you can first create a dictionary and use that. So I think this is much faster than the previous one because it does not use sorting. But mind you that this might give you a TLA because dictionary, the default initial capacity is 8, and as you insert more number of items, the Python has to reallocate the size of the dictionary, and it might TLE in Python. Okay. But in Java, you can specify the initial capacity. So since the maximum is 2 into 10 to the power 5, So you can say that, okay, let the initial capacity be 2 into 10 to the power 5, and the insertion time in a hash map is almost big O of 1. So that will improve your time complexity. Similarly, for the C++, you can create an unordered map whose insertion time is big O of 1, constant time, and you can reserve a space of bucket space of 2 into 10 to the power 5 to improve the time complexity, right? And just check if while traveling only, just check if the element is present, the required element is present in the map. If yes, then simply simply break out of this loop, and this runs in big O of n time. So it is actually much faster than the previous sorting plus 2 pointer approach. So I hope you were able to understand it. Let's move on to the next problem. So let's see the next problem, maximum subarray sum. You are given an array of n integers. Your task is to find the maximum sum of values in a contiguous non-empty subarray. Okay. Now first you can read the input format, and we need to print one integer, the maximum subarray sum, and the length of the array goes till n into 2 into 10 to the power 5. Okay, so and the values are going from minus 10 to the power 9 to 10 to the power 9. Yeah. Now why do we have negatives here? Like if we did not have negatives, the maximum subarray will become the whole array, so there is no point in that question. These negative values make the question interesting, right? And this is a very popular problem, and the algorithm to solve this problem is called Cadine's algorithm. And 2 years ago, when I first tried to solve this problem, I was not able to understand the algorithm. So actually, I think this problem should be in the DP section and not here. But this is a pretty popular problem by the name Cadine's algorithm, so they put it here. So if you are just starting, I would recommend you to just learn this algorithm by heart for now. And as you solve more dynamic programming problems, you will be able to understand it as well. Okay. So I will just try to explain it. Yeah. So first let's understand this test case. So we have 8, minus 1, 3, minus 2, minus 1, 3, minus 2, 5, 3, 5, 3, minus 5, and 2, 2. So obviously there is no point in taking this subarray. So I will just simply discard it for now. I can take this subarray. I can also take this one, right? Then I can take this one. So the sum is 3. Here sum is 1. Here sum is 6, right? And now the sum is 9. Then the sum is minus 4. Sorry, 4. Then I think I can just extend it to here, like 4, 5, 6, 7, 8, right? I think the answer should be 9 here. Yeah. So the answer is this subarray here. Now, so the question is pretty straightforward. Like one possible approach is to just find all the subarrays, like in big O of n square, right? And then for every subarray, you will calculate the sum in big O of n, and then take the maximum. So this will result in a big O of n cube time complexity, which will give you a TLE, right? So you need to optimize it to a solution of big O of n log n or greater than n log n, which is big O of n, right? So I like to solve this problem by dynamic programming. And I think this question is more suited for that, and it should have been in the dynamic programming section. And the solution is very popularly known as the Cadine's algorithm. So the solution is very popular, and you can find it anywhere in the research papers and on YouTube also. if you search for it, you will be able to find this algorithm, right? So let's discuss this. Like I will just write this again. We have -1, p, -2, 5 and 3, then -5, then 2, then 2, right? Now, like, okay, since we have the first digit is -1, then obviously I can discard it. There is no point in having a -1 for the start element, right? Obviously we can start with a positive number, so I directly discarded it. I started with here, so our sum is 3, then we had a -2, so sum is 1, then 5, so sum is 6, 7, 8, 9, and then we had, suppose here was -10, not -5, then should I even consider taking this? Shouldn't I just start my like wait, like for here the sum is 9, right? And if I add this, let's say there is a very big negative number like -20, right? Or even, I mean, like okay, let's say initialize a DP array. I will just go with standard procedure now. So there are 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, what does my DP of I represents? DP of I represents the maximum sum subarray ending at DP of I. Okay. So my subarray must end at DP of I. Okay. So what will be my answer? Answer will be the maximum of all these maximum of this DP array, right? So just take the maximum. First we will have to compute this DP array, and then we will have to find the maximum, right? So how can we find the DP of how can we calculate the what order transition? So any subarray, like if I want to start a subarray, I can either DP of I can either continue the DP of I minus 1, and like whatever is the maximum subarray till I minus 1th index, the previous one, I can either start a new subarray from it, right? Like I will add one more element to the subarray, or I can simply start a new subarray from the current index, right? These are the only two states possible. For every index, like for every index, like I can start a new subarray from -1, or if there was some previous subarray, I can continue it, right? So here will be -1. Then for second index, I can either add 3 to -1, or I can start a new subarray from 3, right? So here the optimal strategy is to start a subarray from 3. Okay. The -2, I can start a subarray from -2, or I can add it to this one, right? So obviously the optimal will be to start to not start a new subarray from -2, otherwise the sum will be -2. I should add it to the previous element, so this will become 1. Then again I can start a subarray from 5, or I can add. So here the optimal strategy is to add 1. This will become 6. Then I can start a new subarray from 3, or I can continue the previous subarray that was till 5. So this, the maximum sum will become 9, because 3 plus 6 is 9. And then let's consider -10. Okay, now I can start a subarray from -10, or I can simply add a 9 here. So the optimal strategy is to add it, right? So this will become -1, then 1, then I think 3, right? And then take the maximum of all these entries. The answer will still be 9, because this subarray is giving me a sum of 9, right? So that is the DP solution. So you can just go for I equals to 1 till whatever, and do initialize dp of 0 is equals to a of 0, array of 0, and then you can do dp of I is equals to dp of I minus 1 plus a of I, comma a of I, and take the maximum of this. Okay, and in the end you will have to take the just take the star max element in the dp array. Okay, and just print it. So that will give you the solution. And now this is requiring you big O of n time and big O of n space, right? But can we optimize it further? So the answer is we can't optimize in time, but we can definitely optimize in space, because we don't need we don't need the full dp array, right? We only need the previous one. So why not only store this in a constant space? So why not we store this in a constant space and not a whole array? We don't need to make this full array, because we at any given time we only need just one previous element, and we have no use of these further previous elements, right? We can store it in a variable, and that will optimize the space and cut down the complexity to big O of one space, and that will be our final solution, right? So let's see the code for this one. I hope you were able to understand it. If not, you can comment down and I will try to make, maybe probably I will make a separate video for this if it was not clear enough. Okay, so let's see the input format. First an integer and there is an array. So first I will take the input integer and then I will make a vector of these of that array. If n is 1, then obviously the first element will be the answer. Otherwise, for this dp array, I'm starting with the minus of the int max, right? And then at any given time, if a plus li is greater than li, then obviously then I will continue the previous subarray. Otherwise, I will start a new subarray from that current index. And at every point, I will take the maximum. So my answer will be stored in the b variable. Same code in Java. First take the integer, then do this, and same code in Python. Okay, so I hope you were able to understand this, and let's move on to the next problem. So let's see the next problem, stick lengths. There are n sticks with some lengths, and your task is to modify the sticks so that each stick has the same length. You can either lengthen or shorten each stick. Both operation cost x, and where x is the difference between the new and original length. And we need to find the minimum cost to do that. Okay, and you can read the input format. We have to print an integer, the minimum total cost. And so let's understand the test case. We have 5 2 3 1 5 2. Basically we want to select, let's say I will select x equal to 0. So if I want to make all the stick lengths equal to 0, then I will have to encounter a cost of 2 plus 3 plus 1 plus 5 plus 2, right? This is basically the sum of the array, and 10 to plus 5 6 11 13, and that will give me a cost of 13. But let's say if I want to have a cost of something greater than 5, something, let's say 10. If I want to make all the stick lengths equal to 10, then it will give me a cost of 8 plus, what is it, 7 plus 9 plus 5 plus, and then one more 8. And similarly, if I want to have a cost of, let's say something smaller, so there are 5, so 1 2 2 3, let's say x equal to 2, then it will cost me 0 plus 1 plus 1 plus 3 plus 0, right? 3, 4, 5. So which will give me a cost of 5, and this is the minimum. I think this is the answer, right? Yeah. So the optimal x was 2, and so this is the answer. And basically we want to find an x value which will give me this minimum answer, and then find out the minimum total cost. This is the minimum total cost, right? Now how do we approach this? I mean, this is actually a very standard problem, and if you don't want to know the proof, I will just tell you the result for this one. So if y is equals to summation of I equals to 1 to n and si minus x raised to power c. So for c equals to 1, like that, then the answer is the median of these discrete values, and for c equal to 2, the answer is average. Okay. Now if you want to prove this, this is not the question, so I will not discuss this, but you can simply differentiate and put it equal to 0, and that will you will arrive at the solution. And for the median case, I will just try and explain you, then I will show you the code. So for proof, for c equals to 1, right, let's first consider a scenario when we have 2 points, like on a straight horizontal line. So if we have a here and then b here, right, and we want to have an x, so there is a quantity y is equal to mod of a minus x plus mod of b minus x, right? If we have x here somewhere or x here somewhere, and one third case is x is in between a and b, then obviously by looking at this I can say that for y to be minimum, x has to be the perpendicular bisector of a and b, right, something in very between a and b. And we can generalize this for n points, that my x should be between the lowest, the minimum of all these values, to the maximum of all these values, right? So somehow, so I can easily say that my first step should be sorting, because after sorting I can say that okay, my x will be between the first element and the last element, right? So this will cost me an n log n operation time. And after sorting, my y is summation of mod of si minus x, but my s is sorted, right? So if s is sorted, then I will try to take x as the as between value as possible, right? So I will say okay, for half of the element x is greater, and for other half x is smaller, right? So then this becomes the summation, like this is from I equals to 1 to n, right? And I can say okay, s1 is smaller than s2 and is smaller than s3, and it goes on to sn, right? Then now if I open this up, like okay, I will take the s1 and s2 out, then this will become summation of I equals to 2 to n si minus x. But now for the s1, x is greater, so it will open like x minus s1 plus, and for sn, x is smaller, so it will open like sn minus x, which is equals to, this term is equals to actually sn minus s1. And I can go and keep on breaking removing the si's, and this will in the end, if I consider the length to be an odd length, then this will become s of n minus 1 by 2 minus x plus sn minus s1 plus sn minus 1 uh, minus s2, and so on, right? And if I want to minimize this term is obviously a constant, and this is the only variable term. And if I want to minimize this, I can obviously my x should be equal to s of n minus 1 by 2, right? but my S was already sorted. So this is the same as the median of the array, right? So this is how we can prove that X should be the median, and that will give me the optimal answer. So I hope you were able to understand the solution, and let's see the code. So first I will take the integer and I will make this array and just sort it and take the median of the median value as your X, and then you can just sum them, right? Similarly, we have the Java code. I'm using radix sort to sort it in to improve the time complexity, and then again take the median and just uh, add your values. And similarly, we can do it in Python, right? So I hope you were able to understand it. Let's move on to the next problem. So let's see the next problem: missing coin sum. You have n coins with positive integer values. What is the smallest sum you cannot create using a subset of coins? So you can read the input format, and we need to print one integer, the smallest coin sum that we cannot create. So n goes to 2 into 10 to the power 5, and okay, let's first understand this test case. So we have 5 coins, 29127, 29127, right? Yeah. So in this, like for 1, we have a 1, so we can create it. For 2, we can either use, okay, so we have a coin of 2, so we are able to create it. For 3, we can use 2 and 1 together, and we can create it. For 4, we can use 2 and 2, and we are able to create it. For 5, we can use 2, 2, 1, and this works. But for 6, for 6 we can't create because we have 2, 2 and 1, but 1, 1. But now the next coin, but the next coin we don't have anything. So we are not able to create 6. So 6 is our answer, right? Yeah. And n goes to 2 into 10 to the power 5. So it is asking for a big of n log n solution, right? So one thing is, and just by looking at the time complexity, we can say that the what are the possible things that we could how can we what are the possible ways to approach this problem. One is the subset sum, but this goes for time complexity big of 2 raised to power n, right? So we will so this will give us a TLE, so we can't use this. Another maybe, like I don't know, maybe we can use binary search. That might come to your mind if you are looking at this n log n. So basically you search for sum. If you can create it, then you search for something smaller, and then you try to minimize your answer. But you can't use this because there is no predicate function here. If there is no predicate, you will not be able to solve this problem using binary search. So the rest thing is what is left is sorting. So we have eliminated 2 of the possibilities. Now what is left is to use sorting to somehow solve this problem. Okay. So we have 29127, 29127. So if we sort this, 1, 2, 2, 7, and 9, right? Like for sum equals to 1, like I can say if first element is not 1, because coin can't be negative, right? the coins only go from 1 to 10 to the power 9. So if my first element is not equal to 1, then my answer is 1, right? Otherwise it will be at least 2, right? Now for sum equals to 2 to be my answer, my second element, what should be my second element? Like, okay, I'm saying the first element is 1, but if my second element is can be either be 1 or 2, right? If I have 1 comma 1, then I can make a sum of 2. If I have 1 comma 2, then I can simply consider this coin and make a sum of 2, right? So 2 will be answer. So my second coin should be a 1 or 2, right? Now how about for sum equals 3? Like, I know my first coin should be 1 comma first two coins can either be 1 comma 1 or 1 comma 2, right? If this is the case, then I need my third coin to be at least 1, right? It can be a 2, 1 1 2, or it can be 1 1 3, doesn't matter. Then I will be able to make a sum of 3, right? So that means if I okay, but if I already have 1 and 2, I don't even need the third coin, right? So, so what is happening here? Like if I see 1 comma 1, I can't have a 4 here. Why? Otherwise I will not be able to make 3, because like you see the pattern here, right? Like if I have like if I take the prefix sum, so my prefix sum is 2, and if I place any coin, so okay, basically if I have 1 comma 1, my prefix sum is 2, like the cumulative sum of these coins is 2, right? Now I have to check if I can make 3. Like I am for sure that I will not be able to make 3, right? So what should be my next coin to make at least 3? My next coin should not be greater than 3. So if I have 1 comma 1 comma 1, I will be able to make 3. 1 comma 1 comma 2, I will be able to make 3. 1 comma 1 comma 3, I will be able to make 3. But if I have 1 comma 1 comma 4, I will not be able to make 3, and 3 will be my answer. So do you understand it? Like so if I have 1 comma 1 comma 1, my answer will be what? 3? Sorry, 4. If I have 1 comma 1 comma 2, take the prefix sum 2 3 4, my answer will be 5. I will not be able to make 5. But if I place any integer, right, uh, this is my answer for these coin values. So if I have 1 comma 1 comma 3, my answer will be 6. I will not be able to make, I will be able to make till 5. How? So let's consider this set of coins. Like if I have 1 comma 1 comma 3, then I am able to make 1, I am able to make 2, I am able to make 3, I am able to make 4, I am also able to make 5, but I will not be able to make 6, right? So my next coin should be at least can range from 1 to 6, right? And I will be able to make that coin. How? Suppose my next coin is 2, so 2 3 4 5 6, like that. You can choose any next coin can be anything between 1 and 6, but it can't be greater than 6, otherwise I will not be able to make 6, right? So first thing we do is sorting. Second thing is we check the prefix sum, and then if my prefix sum of I plus 1 is less than next coin, so I will say if is less than coin I plus 1 is less than coin, that means my answer is equals to prefix sum I plus 1. So that is the algorithm here, and we will use this to find the answer. So I hope you were able to understand it. If not, you can just go back a few minutes and then watch this again till you are able to understand it. I will recommend you to write this on your own and try to come up with it. Okay. So let's see the code. So first we sort the whole array. Okay. And then I have to check if the first element is 1 or not. If not, then that is the answer. Then I will take the prefix sum, and if prefix sum plus 1, if prefix sum plus 1 is greater than k, if coins is greater than prefix sum plus 1, then that is the answer, and that is what I do. Similarly for the Java code, here I'm using radix sort to make it faster, to make the sorting part faster. And this is the same thing. If prefix sum plus 1 is less than the xi, then my answer is prefix sum plus 1. Similarly for the C++ code, I will taking the cumulative sum, and if if the coin size is greater than prefix sum plus 1, then that is the answer. Otherwise, you reach the end of the array and you have to print the prefix sum plus 1 as your answer, right? So I hope you were able to get it. Let's move on to the next problem. So let's read the next problem, collecting numbers. Your task, you are given an array that contains each number between 1 and n exactly once. Your task is to collect the numbers from 1 to n in an increasing order. Okay. So on each round, you go through the array from left to right and collect as many numbers as possible. And it is asking for what will be the total number of rounds. Now you can read the input format, and we need to print one integer, the number of rounds. N goes to 2 into 10 to the power 5. And so it is basically asking for a solution of big of n log n time or better. And so let's just try to understand the sample test case. 5 4 2 1 5 3. So let's say this is the first round. So I will be able to collect and we have this array. So in the first round, I will be able to collect 4 and 5. In round 2, I have 2, 1 and 3. So I will be able to collect 2 and 3. And in the third round, I will be able to collect 1. So 3 rounds are required, and hence the output is 3. Okay. Now to solve this, there is a simple observation that like instead of going like this, round 1, round 2 and round 3, why don't we try to collect 1 first, then 2 and 3, then 4 and 5. Like that will give us the same answer, right? So we have 4 2 1 5 and 3. So I will first try to collect 1, then so I will just like what are the indexes. So indexes are 1 2 3 4 and 5. I will just ask what is the index of 1. 1 index is 2. What is the index of 2? It is 2. Index of 3. So index of 3 is 1 and 4 index is 1. Wait, so index of 3 is 5 and index of 5 is 4. So obviously I need at least 1 round. So I'll start with 1. So I've collected 1. Now can I collect 2? No, because in that same round I can't collect the number 2 because the index of 2 is less than 1, right? So I will have to increase this. I will need at least one more round to collect 1 and 2. Now 3 is in the same round, but because the index of 3 is greater than index of 2, But now I can't collect 4 in the same round because index of 3 is less than is more than index of 4, right? I'll have to increment this by 1, and then I can collect 5 in the same round because index of 4 is less than 1, less than 5. So I just need to first make this index array, which I can probably store it in the same array, and then I will just go from left to right, just checking that if L of I is greater than L of I plus 1, then I have to increment the round. And so this is a very simple question, pretty easy and straightforward, and the time complexity is big O of n, right? And the space complexity, we are using the same array, so we don't even need any extra space for this one. But however, if you want, you can also use hash maps for this one to store the values and the indexes to map to make a map of this. You can probably use a hash map also. That will also lead you to the same time complexity. So let's see the code. First I'm taking an integer, then I'm making an array, and notice I am not saying x of I equal to k, but x of k equals to I. So I am forming this map in the same array, okay, and my array is n plus 1 in length, so it will fit in it. And next I just have to check if x of I is greater than x of I plus 1, then I have to do answer plus plus, and then I can print the answer. Same code for Java and Python. So let's move on to the next problem. So let's read the next problem, collecting numbers 2. You are given an array that contains each number between 1 and n exactly once, and your task is to collect the numbers from 1 to n in increasing order. On each round, you go through the array from left to right and collect as many numbers as possible. Given m operation that swap the two numbers in the array. Your task is to report the numbers of rounds after each operation. So this is basically just a follow-up problem, and like in the previous problem we had O, and so like in the previous problem we had 4 2 1 5 3, and the number of rounds required were 3. Then we need to swap 2 and 3. So position 2 and 3, if we swap it, so it becomes 4 1 2 5 and 3. The number of rounds required will be 2, right? And so we need to report 2 as our answer. And then if we swap 1 and 5, so 4 and 3 will be swapped. So now the new array becomes 3 1 2 5 and 4. So the number of rounds will be 1 2 and 3. So we will report 3 as our answer, and then we will swap 2 and 3 again, and then we will get 4 as our answer. So I think it is pretty straightforward. Like it will be very similar to the previous one. We will create this array, and when we are given to swap, like if it is any number between 2 and 4, basically any number except the first and the last, it has some interference with the previous number and some interference with the next coming number, right? So first we need to remove that interference, and then we will swap these two values, and then we will update the interference. Now if the number is either the first element or the last element, I mean 1 or n, then obviously if it is 1, then we don't need to check the previous interference, and if it is 5, then we don't need to check the next interference, right? So I think it will become more clear if you see the code instead of just listening to this explanation. So I think till here it is it is similar to the collecting numbers one. Now I'm creating a set of pairs, and if the value of n plus 1 is less than or equal to n, that means if it is something like 1 to 4, then it is interfering with value and value of that plus 1 till the last element, right? And if it is greater than 1, that means if the value is greater than or equal to 2, then it is interfering with the previous and the next. Otherwise it is not interfering with the previous one, right? And so these are the 4 cases. First we will store these 4 cases, and then we will, like here we did positions I greater than positions I plus 1. We are just doing the reverse of it, trying to undo that. And after swapping the values and the positions, we are adding the we are just doing that same thing that we did here, and then we need to print the answer. So I think you should just try to code it yourself, and then you will be able to understand it better. Similarly, the code in Python, and this is the code in Java. For Java, I mean, if you are using pairs, then you need 2 more methods, the hash code and the equals. If you are doing it this way, then you need this. Otherwise, it might give you a wrong answer. Then pretty much the same thing. So I hope you were able to get it. And let's move on to the next problem. Okay. So let's read the next problem, and the problem name is playlist. You are given a playlist of radio station since its establishment. The playlist has a total of n songs. What is the longest? What is the longest sequences? Uh, what is the longest sequence of successive songs, which where each song is unique? So you can read the input format, and we need to print the length of the longest sequence of unique songs. And the constraints are till n is till 2 into 10 to the power 5. So it is asking for a big O of n log n type solution. Okay, so let's first understand the test case. We are given this array, and we need to find the subarray with maximum length in which there are no duplicates. So one possible array may be, I mean, let me use a laser for this one. It may be this one. We could consider this one as well, but we can't consider this because 1 is repeated twice. So we will not be able to consider this. So one possible is this one. Then we can also consider this, and so on for 2 element. We can also consider this one. So 3 can be our answer. A length of 4, maybe this one, and we can all, and I think the maximum subarray is this. So the length is 5, right? So this is why the answer is 5. Now, how do we go about this? Like one way is obviously to find all the subarrays in big of n square, and then we need to check for every element. We can probably create a hash map or a set to efficiently check that if that subarray contains any duplicates. So this goes to big of nq, or probably worse if you are using some naive searching algorithm. So this will give you a TLE. Now, like how do we go about solving this problem? So 1 2 1 3 2 7 4 2, right? So the easiest implementation will be using 2 pointers. Like we will have 2 pointers at the one will be like start pointer and the end pointer, and I will shift the start end pointer, like okay, and then I will check, like if I move this, then and this is repeated, like if I move this end pointer to 1, then I know that 1 was repeated in my array, right? So what I will do, I will increment my start pointer by 1, right? So start comes here and then end comes here. So I will keep on incrementing my end pointer till I encounter something again. So when my end pointer reaches 2, okay, so currently my answer was equal to 2 because they were there. Now when my end pointer reaches here, that is equal, and then I have to search for the previous occurrence of 2, which was at here, and I will shift it by 1. So now my start pointer will be pointing here, and then I will again calculate the distance, and if it is greater than my answer, then I will update it here, right? So after this, I will keep on incrementing the start pointer again till I encounter 2 again, right? It will reach somewhere here, and then I will check the previous occurrence of 2, which was here. So I will have to increment my start pointer by 1. My start will point here, and my new sub array is 3, right? Obviously at each step I will keep on maximizing the answer, so it will be equal to 5. But whenever I encounter this, I will create a hash map of the occurrences, and then I will uh, increment my start pointer by the previous occurrence plus 1. Like what was the index at which I saw this, and then I will increment my answer by 1. I will increment the start pointer to that location by 1. So I'm sure that, okay, before this there were no 2's in the remaining subarray. So I hope you were able to understand this. Let's see this in the code. So first, this is the Python code. We are importing the default dictionary. Basically what it does is when we try to inspect a value that is not present in the dictionary, it does not throw us an error, but it gives me the default value of int, and that is 0. So if if x is not in the last in dictionary, it will give me a 0 and will not throw any errors. Okay. Now n is the input, l is the list. Then I'm creating 2 pointers, start and end. Obviously end will have to increment till the end of the array, right? What we are concerned about is the start pointer only. So as I increment x, I have to increment the start pointer to the last scene. Either it can stay till 0, or in the last scene I am storing the end plus 1. So I can even do remove this and add here, but or we can do this like this. So both means the same thing. So since I stored end plus 1, I can keep it like this here. So start will automatically move to the previous occurrence plus 1, and every time at every step I need to maximize my answer, and then this will be my answer. So let's see the C++ code. And in C++ you must use this. You need to first reserve the last scene, the unordered map capacity, and then it is pretty much the same thing. And then this is the Java code. I'm using hash map, and yeah, pretty much the same thing.